how does the MACH reactor improve flotation?
Now, the MACH reactor targets very fine particles in flotation that ordinarily you wouldn't be able to float, right? So let's just take a step back and talk about the three sub-processes of flotation, or the three probabilities of flotation. The first one being the probability of collision, and there it's the probability of the particle that you want to float actually colliding with the bubble. The second one is the probability of attachment. That's after they collide, do they stay stuck together, right? And then the probability of detachment is, which you don't want to happen, is that after they collide, that they actually move away from each other again and detach, because if that happens, you're not going to get the flotation process, will not work. So why is it difficult for a fine particle to attach to a bubble? And the reason is, it's because of its a low mass. It has also very low inertia, and what it does is it gets stuck in the streamline around the bubble. So there's a rising bubble, and that's a falling particle, and what happens is there's a water streamline around the bubble. It's almost like a surfer on a wave, and the fine particle will just surf past that bubble and it won't collide, it won't touch it. So you will not even get any collision happening, and if that doesn't happen, there's no chance that you will get any attachment, and flotation is impossible. So that's in a conventional system without the MACH reactor, right? So how does the MACH reactor fix that? And that's where the magic happens in the Venturi, this pico-bubble formation that we talk about, the pico-bubbles that form on the particle surface. So it's almost in the Venturi, you have the particle that you want to float, the fine particle, giving birth to these bubbles. So that's where the cavities form. The bubbles actually form on the particle. So you don't have to worry about a probability of collision. There's no probability there because it's actually growing. It's starting its life on the bubble. So they're already together from the word go. So it's helping with this collision and attachment probability in flotation. That's almost 100% in the MACH. So you know you will form these pico-bubbles, and you can imagine it as a sugar-coated donut. So that's the relative size, so the donut being large and the pico-bubbles being very, very fine on it. And then that's the first step. That's the nucleation step in the MACH. Then those fine particles that have the pico-bubbles attached to them will then aggregate. And the reason they aggregate is they move to a lower energy state. So when they are together like that, they are in the total energy state is lower than when they are separate. So they will, everything in nature wants to go to a lower energy state, including myself. I love lying on the couch. But these particles will then stick together, form this aggregate, and now what happens is they start to look like a larger particle, because you've got 3, 4, or 5 of these little particles that are stuck together. They look like a larger particle, and when you present that to flotation, the flotation size, so this is a float bubble, it's a larger bubble. That float bubble then recognizes this cluster or the aggregate as a large particle and picks it up, and then you have the last step, levitation. So you then achieve the flotation process on a very, very small particle, which, as I've said before, you would just not float at all in conventional flotation. For more information on the MACH, gold ore, and how we are challenging and changing the world, please visit www.goldore.org.